One, I'd like to show you a couple of video lectures on the sections that you need for this week's homework. And the first section is on 11.3 and it's exponential functions. And exponential functions look like this following form as shown on the screen, where f of x is equal to b to the x, and b is just a constant number that's greater than 0, and b cannot equal to 1. The reason it's called an exponential function, as you probably noticed, that x is in the exponential exponent part. So let's just see a couple examples. The first part I want to show you is about graphing. So suppose we're looking at f of x is equal to 2 to the x. And what I want to show you is what the graph would look like. And then we will go ahead and talk about transformation of this function. So let's make some table of values, and I'm going to go ahead and choose some negative as well as positive values so you can see a pattern to it. Now we are going to find out what what the y value is when x is equal to these according values. So for example, this part y is equal to 2 to the negative 3 power, which, as you remember, it's 1 over 2 to the third power, which is 1 over 8. So I'm going to fill in the table now. As you can imagine, this is 1 over 8, 1 over 4, 1 over 2. 2 to the 0 power is 1, and then 2, and then 4, and then 8. Okay, so let me show you on the side what the graph might look like. So this is the graph, just as a sketch. And it's going to go through 0, 1. Okay. And when x is very negative, you're going to get a very small y value. Now notice that when x is very, very negative, you're going to have very small y value, but y value will never be 0. And as x gets larger, y value increases very quickly, and that's one of the special property of exponential function. Now what I would like you to do is think about some of the transformations we have learned from quadratic functions, and I want you to think about what a function would look like if I were to just change a little bit components of it. So for example, if I want you to look at g of x is equal to 2 to the x plus 3. So if you're looking at this function, 2 to the x is the same as previous, and we are adding 3 units behind every y value. So what this is going to do is going to shift 2 to the x. Can you imagine what's going to happen? It's going to shift up 3 units. So the graph, everything remains the same except every point is moved up 3 units. So instead of going through 0, 1, now it's going to go through 0, 4. And then previously, remember our value of the values of y is approaching x equals, is approaching x-axis. Now it's going to approach this line, which is y equals 3. And the graph is exactly the same as before and have the same shape, and I apologize that the graphing is not as nice as it could be. Okay, so that's the main part. Main thing about this section is I want you to understand how the graph will shift. I want you to look at a couple more. And now let's look at another example. And let's look at h of x is equal to 2 to the x minus 2. Okay, I apologize, the green doesn't seem to show very well, so I'm going to switch back to black now. If you recall, when we were learning quadratic functions, and in quadratic functions, if you do something to the function, okay, so 2 to the x was the original function, right? Now you're subtracting 2 units to the x values. What that does, because you are doing subtracting 2 before you take the exponents, this is going to shift 2 to the x to the right 2 units. Okay, so let's just look at the graph one more time. Sorry, the pen is not working very well. So this is your x-axis, this is your y-axis. I'm going to first graph 2 to the x again. And remember, that goes through 0, 1. And what that's going to do, 2 to the x minus 2 is going to shift to the right 2 units. So instead of 0, 1, now you're going to have 2, 1 right here. Okay, and then everything else remained the same. Okay, does this make sense at all? Okay, and we'll finish this little lecture with the kind that is a exponential decay. And an exponential decay function looks like this. F of x is equal to 1/3 to the x, or if you think of this as 3 to the negative 1 power to the x, that looks like 3 to the negative x. So these two are equivalent, okay? And both of these, they're exactly the same function, and they are referring to exponential decay function. And as you can imagine, right, if you make a table of values again, okay, if you are thinking about it in this form, right, so the larger the x gets, the smaller outcome you will have, right, because you're taking the fraction of it. And then when x is negative 1 power, remember, if you're looking at it in this form, that's just 3 to the negative of negative 1, that's 3 to the 1 power. So when x is negative, you actually have positive y value. So in a way, this is called an exponential decay, because as x gets larger and larger, you actually have smaller y value. So this is what that looks like. Okay, so this graph, basically, if you think about 3 to the x, 3 to the x will look like this. So this is 3 to the negative x, right? So 3 to the negative x, let me write it on the side. 3 to the negative x is 3 to the x reflected across the y-axis. Okay,